Okay. Hello, everyone. I hope you are having a lovely night. So, inspired by a student that had a question about some questions of the makeup exams and also practice exam that I posted, I thought this would be nice that I record a video to go through the questions or similar questions that I'm going to give you tomorrow in the exam. So I guess now I'm curious to see how many of you actually watch this. But if you do, I feel like you'll be fine for your exam tomorrow, or maybe you will be regardless. So remember that valence electrons are important while we're dealing with bonding, okay? And covalent bonding the same. There are like valence electrons that are active and electrons would be shared in covalent bonding, and then in ionic bonding, electrons are being transferred, but we're dealing with valence electrons, right? Kernel, remember, nucleus plus field shell electrons, not valence electrons. Okay. And remember, when we write the Lewis structures, for instance, for neon, we have like 8 valence electrons because neon is in group 8A. So we write 1, 2, 3, 4, 5, 6, 7, 8. And we name the element, or we call it kernel, right? Because it represents nucleus with field shelled electrons. We put valence electrons around neon. Does that make sense? I hope so. The maximum number of electrons that occupy the third shell. Remember, third shell, n equals 3 has s, p, d orbitals, and then I write 3 because like it's the third shell. S orbitals can have like 2, we have like 3 p orbitals. Each of them have like 2 electrons, remember, 6. And then the same thing for like, or similar thing for d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you add 2 plus 6 plus 10 plus 18. I hope that makes sense. How many valence electrons carbon has? Carbon is in group 4A, it has 4. Okay. Which of the following has covalent bonds between their atoms? Metal plus non-metal is ionic. Don't get confused. So these are all metals. So BF3 would be covalent bonding. Chlorine, is in group 3. So it ends with 3S, 3P, and it's in group 7A. So it should have like 2 plus 5, 7 valence electrons. Okay. So helium is in, row 1, period 1. It's in group 2. So it would be 1s2. Sorry, group 2A, I meant. Oh, I just messed this up. So, I just designed this question to confuse you, and I just confused myself. So helium, if you look at the periodic table, helium is an exception. You have like your periodic table like this, right? And then we're kind of like this. Just messing this up. So helium is in group, here. I guess this is like a better, I can draw a periodic table. So periodic table. So you have like these 2 elements, hydrogen, right? Helium here, and then you have like, group, 1A, 2A, and then here you have like your transition metals, and then I guess I just get rid of this one that I wrote here, and then you have like, oh, says my microphone isn't used. Maybe I just have like smaller. Oh, okay, I can do this. Never mind. I was just thinking that I have like space issues. Okay, so here I have like lithium, beryllium, right? And then here, if I want to have like the same, I have like lithium, beryllium, I have boron, I have like carbon, nitrogen, oxygen, fluorine, neon, and then here helium is in group 8A or like 18. These are like the rest of elements. I mean, we're not that concerned about them. So yeah. So basically remember that hydrogen, you know, helium and lithium were exceptions that they wouldn't reach an octet, you know, and helium belongs in group, you know, 8A. I mean, I thought I asked that. I don't know why I started talking about this. But anyway, remember the electron configuration is 1s2 because it has like 2 electrons in its outer shell. Okay. And then nitrogen, I just wrote it here. It's in group 1A, 2A, 3A, 4A, 5A. So it has like, you know, 5 valence electrons. But in order to know the number of electrons in general, you look at atomic number. Atomic number, my book was about to fall. Atomic number of nitrogen is 7. So 7 would be number of protons, which for the nitrogen atom equals number of electrons, right? So it would be 7. Which element does not form a covalent bond with chlorine? The one that is metal, right? That is ionic bonding. And which elements belong in the same group of family in the periodic table? I just wrote that here. Helium, neon. Write the structure for 2-methylhexane. So what you do is that first look at the base name of the alkane, right? This is the main chain. 1, 2, 3, 4, 5, 6, 2, 4, 6. I expect you to know, methane has 1 carbon, ethane, remember the general name of alkanes, 2n plus 2, N=1, methane, N=2, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Anything that I can remember, you can easily remember. So 1, 2, 3, 4, 5, 6, 2. Then carbon number 2, we have a methyl. Remember, is methane that lost the hydrogen. So this is CH3, right? So here, remember, valence of carbon is 4. So it should have 4 bonds. It already has 1. We'd be having 3 hydrogens here. 2 here, 2 here, 2 here, 3 here. So it would be CH3, 2, C, CH2, 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 CH3, which is, oh, again, sorry, here we have like 3, so we want 1 hydrogen here, 2. CH3, 2, CH, CH2, 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 CH3, okay? Write 2 and 2 dimethylpentane. Look at the base name, pentane. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 and 2. Di means 2. Methyl, CH3. What would this be? You tell me. CH3, 3, C, CH2, CH2, CH3, which is this one, right? Which one is this? Look at the base name. Don't be scared. Heptane has 7 carbons. 1, 2, 3, 4, 5, 6, 7. 2, and then I name them. 1, 2, 3, 4, 5, 6, 7. 2, 3, 6. 2, 3, 6. Trimethyl, 3 methyls. Right? And we didn't even write hydrogen for all of them. So this is wrong. This is wrong. right? We should have like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That is right, but you see the branches, how they are? They're not like this. And between these two, this is 1, 2, 3, 4, 5, 6, 7 carbons. But what about the other one? 1, 2, 3, 4, 5, 6, 7. That is 7 too. But C, this one would be 1, right? And I guess this one would be 2, 3, 2, 3, 7, right? Trimethyl heptane. We're looking for 2, 3, 6. So that's why this is the answer. I hope it's clear. Write the structure for 4-ethyl 2 and 2 dimethyl heptane. So heptane 1, 2, 3, 4, 5, 6, 7, right? I'm using my blue. 1, 2, 3, 4, 5, 6, 7. 4-ethyl. It would be like this, right? Or we can write C2H5. Remember, ethyl C2H5 is ethane that has lost the hydrogen. Di means 2, methyl, which is CH3. 2 and 2 of CH3s. Now let's see which one is this one. So, you can have like the branches both at one side. Don't get confused. The point is that this doesn't have any branches like 1, 2, 3, 4, 5, 6, 7. This is just heptane itself. And then this one has like 3 branches, 3 methyls. It doesn't have any ethyl, so that is wrong. So between these two, you see 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Even without writing the name, this is something, 2 and 2 dimethyl. 1, 2, 3, 4, 5, 6, 7, 8. This would be like 2 and 2 dimethyl 4 ethyl ethyl octane. And remember, when you write this, you should write ethyl first. So basically, we write this as 4 ethyl 2 and 2 dash, and it won't be that strict about dashes and stuff. You should know that, but I don't stress so much about it. Diethyl heptane. So remember, write ethyl first, because alphabetically, just when writing, we do that. But octane, I can just not copy what I wrote about octane. So that's why this is wrong and this is the answer. I hope that is clear, kind of. But remember, you can have branches through here or two at the same site. Don't get confused. These are 2 methyls. This is 1 ethyl. Okay, is the following IUPAC name correct? 3-ethyl pentane. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The third carbon have an ethyl, which is C2H5, right? So you count this, 1, 2, 3, 4, 5. Even this direction, they have like this, this is, the same number. It has the same number of carbons. So it's basically, this can be considered the longest chain. And either direction we go, we encounter that the third carbon. So this name is correct. But what about the other one? why that one is wrong. If I write heptane 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, it says 5-ethyl. I write an ethyl, right? And 3-methyl. Here I have a methyl, or maybe I put the methyl the other side, so I have more space here. Okay, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. This would be also the same number of carbons, so that is right. You know, there's no problem with this. But remember, if I go this direction, 1, 2, 3, I encounter the methyl branch. If I go the other direction, name 1, 2, 3, I encounter an ethyl group. So both of them are the same distance, but now I go to the direction that is alphabetically prioritized. So I should say 3-ethyl, 5-methyl heptane, right? So that's why this name is wrong. Name this compound. So remember, this is the longest chain, and we go this direction because we have, like, you know, 2 branches. If I go this direction, 1, 2, 3, 4, I reach, you know, the carbon, you know, the branch in the carbon number 4, but this direction I reach 2 branches in the carbon number 2. So 1, 2, 3, 4, 5. So it would be 2 and 2 dimethyl pentane, because I have 5 carbons in the main chain. Which one is tert-butyl? So I discussed that in detail, you know, during our lecture the other time. So I answer to the student when I'm done with this. Tert-butyl is this one. And just, you know, go back to the slides that we had, you know, and I might be able to just like show that real quick, you know. Oh, I guess, you know, I just talked about the, you know what I did? Yeah, it just was like I didn't have a slide. The students asked questions. So I might be able to just like show you the book, I guess. Or I can just write them down, I guess. Draw some stuff. I have everything all over the place. Okay, tert-butyl. Remember, you know, and I talked about this in detail in the class, so I'm not gonna, you know, repeat everything that I said before, but know that this is, do you see that? You know, it just automatically goes to this hand feature, or like eraser feature. CH3, CH2, 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 this is butyl. CH3, CH, CH2, CH3. This is sec, basically secondary butyl. This is isobutyl. And this is tert-butyl. And I'm going to ask you, you know, what type of isomers these are. It would be constitutional or structural, okay? But as of right now, you know, comparing these guys, you see that, you know, tert-butyl is exactly this one, okay? How many carbon atoms is in a propyl group? Remember, propyl was a propane that lost a hydrogen, so it has three carbons. What is the name of this? It's cyclo. It has 3 carbons, right? 1, 2, 3 would be cyclopropane. Which of the following represents 2-methylpentane, you know? So pentane, you should be just expert on this, you know, right now, I hope. So 2-methyl, you know, pentane. And if you write this, you know, it would be CH3, this is CH, it would be CH2, CH2, CH3, right? And, you know, we can also depict this as a CH3 here. We can also write them like, you know, your book does sometimes like this, you know, 1, 2, 3, 4, 5. So I have one extra here. I delete this, right? And you can write it the other direction, CH3, right? So these are basically the same thing. So you count, you know, here, 1, 2, if I want to write it, you know, abbreviated formula would be CH3, 2, CH, CH2, CH2, CH3. You see why the first one is not correct? Because I should have 1, 2, 3, 4, 5, 6 carbons overall, because 5 is in the main chain, right? 1 is the branch. So this one has like 1, 2, 3, 4, 5 overall. So that is wrong. It should have another CH2. But this one, you count, you know, 1, 2, 3, 4, 5 on the main chain and 1 branch. Can you see that? So here, 1, 2, 3, 4, 5, but where is the branch? We have like C5, H, you know, 6, 8, 10, 12. You see what is this? C5, CN, H2N plus 2. This is pentane. It doesn't have any branches. And this is like a lonely, I don't know. 1, 2, 3, 4. It's not R. It has carbon on each side. This is CH3, 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 CH. It's not what we're looking for. I just don't bother to say the name. You can email me, you know, and ask about its name. You know, I'll be really impressed if you do that. Write the IUPAC name for this compound. Oh, I was like, where is the compound? I wrote so many things that now. Okay, you see, first of all, you have carbon here. You have 4 carbons that is, you know, in a, in a cycle. We call that cycloalkane. So right now, you know, this is a cyclobutane. So far, you know, I mean, I guess, you know, I didn't help you here much. I guess here, yeah, here you don't have cyclo. So this is not the answer. Here you don't have cyclo. That is not the answer. And then remember, you have like 2 branches here. So you start naming there because you have more branches. So 1, 2, 3, 1, 2, 3, either direction you get to the bromine in the 3rd carbon. So it would be 1 and 1 dimethyl 3 bromo. But remember, when you write that, rename it here because you have like start naming the carbons here because it has like more branches. But when you write it on the paper, you write bromo first because that's alphabetically prioritized. Let's work on this one. 1, 2, 3, 4, 5, 6. It would be cyclohexane, right? And here I actually didn't help you much. I wrote cyclohexane on all of them. But where should you start naming the branch? That can be tricky, right? So here we start with the one that is alphabetically prioritized. We have methyl, ethyl, methyl. So we start here, right? So we say 1, and then we want to encounter the second branch sooner. 2, 3, 4, 5, 6. So we say 1 ethyl, 2 and 4 dimethyl. Okay. Is the following IUPAC name correct? Nonane. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hopefully I wrote 9 of these. 4, 6, 7, 8, 9. I did actually. 3 and 6 diethyl, right? 3 methyl. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 2. So this is correct in the sense of the main branch or like main chain, sorry, main chain. But going from this direction or that direction, we should go this direction, right? Left to right, because we have 2 branches here. So because we have more branches or encounter the third branch sooner, we go this direction, right? So if this branch was like here, you know, we would go right to left, okay? But here we have like, here the distance is much more, I guess. So can we find anything wrong with this? I couldn't, so I say this is correct. Straight arrows represent, you know, study the arrow formalism. I put that in the study guide too. They point from reactants to products in chemical reactions, straight arrows. Which of the following represent butane? C4H10, right? H10, right? CnH2n plus 2. So it would be C4. So this is C2H6. This is not. You should have 4 carbons. Do you have 4? No. Do you have 4? No. Do you have 4? And then the number of hydrogen also, are they 10? Add them up, like 3 plus 2 plus 2 plus 3 would be 10. Which of the following is not an ethyl group? So you saw in your book, you can write et. C2H5, this is again C2H5, but this is C2H6. Remember what it was? Ethane, not ethyl. I had a classmate in college that he always would look out of his glasses. And one of my friends was saying, why does he wear glasses? He always look like this, you know. And sometimes when I look at my video there, I see that I'm looking like this, and I'm like, why am I wearing glasses? Anyway, which of the following names is correct? So this is kind of like more work, because you should write, these structures and then see which one is correct. So wow, and 3 of them are incorrect. So that is kind of like time consuming question. So let's start with the first one. Pentane. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 ethyl, right? C2H3. 3 methyl, CH3. So you see why this structure is wrong, because this chain is the longest, which has like 7 carbons, right? This is wrong. What about the next one? B. Heptane. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 5 ethyl, 3 methyl, right? So what about this one? You see that Y, if you go both direction, we reach the branch on the 3rd carbon, but which direction should we go? You see here we have methyl, here we have ethyl. So this is alphabetically prioritized. So actually we should name this the other way. 1, 2, 3, 4, 5, 6, 7. So the name should be 3 ethyl 5 methyl. That's 3 ethyl 5 methyl. So that's why the second one is wrong. Let's do the third one. I'm going to change the color. And it's kind of like cool that you can see that too. When I write it on the board, you cannot see my palette. Pentane. 1, 2, 3, 4. Pentane is like 5. 1, 2, 3, 4, 5. 3 ethyl. 5 methyl. You see that why this is wrong? Here we should name it this way, because we encountered the branch first on the carbon number 1. So this is why this is wrong. And always answer all the questions, read all the questions. So even if you're sure that this is the answer, unless you're literally, don't have any time and I'm going to just like force you to give me the exam, you should also read and solve the last one. So methyl heptane. 1, 2, 3, 4. Heptane has 7, right? 1, 2, 3, 4, 5, 6, 7. 5 methyl, 3 ethyl. Okay, so here alphabetically is prioritized. So we name this way, and I cannot find anything wrong with it. 1, 2, 3, 4, 5, 6, 7. This is also 7 carbons, so this is correct. Which of the following represents third butyl? You know, we just went through this, just like remember these things, you know. And which of the following is cyclobutane? Butane has 4 carbons, so 1, 2, 3, 4. What is the Lewis structure for carbon? It has 4 valence electrons. We write the kernel, 4 valence electrons. So this is this one. Write an equation for the formation of a chlorine molecule from 2 chlorine atoms. So Lewis structure of chlorine is in group 7A, 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. So chlorine plus chlorine becomes the chlorine molecules. They share electrons, right? 1, 2, 3, 4, 5, 6, 7. And we denote the covalent bond with the dash or like 2 dots, right? Plus heat, they release lots of energy. Which of the following bonds are polar covalent bonds? Choose the best option among given ones. You know, NaCl, NaBr, and both of them are ionic. So they're not covalent. And what am I writing? Ionic. Br and Cl, they are both nonmetals. And the reason I said choose the best given option, you know, because some people argue that electronegativity of Br and Cl is really close, so they can't be considered polar. That's why I told you choose the best option possible. But still, since it is different, you know, among these options, that is the best option because at least there are covalent. Okay, so in your exam, I don't give anything that is like problematic or like there are like inconsistency between opinion that scientists have or like scholars like us. Draw the structure for C3H6 having 1 carbon double bond. So we count like or we write the number of hydrogen. As you see, you know, here 1, 2, 3, 4. Maximum carbon can have like 4 bonds. So that's why you shouldn't do what I just said, right? And here we put hydrogens, right? And here we also put hydrogens. And we should make sure that we don't have more bonds than needed. And 1, 2, 3, 4. And C3, 1, 2, 3, 4, 0. So we said C3H6, 1, 2, 3, 4, 5, 6. So that's why I just eliminate this bond here. And let's see what I did wrong. Okay, can you see what I did wrong? Again, remember the valence of carbon is 4. It has maximum 4 bonds. You see that I put like 1, 2, 3, 4. So I cannot have this here. So I just like simply erase this. And I want to have like, you know, here 1, 2, let me change the color. 1, 2, 3, I should have 1 more bond for carbon. And then when I do that, I reach this structure here. And also you can see that 1, 2, 3, 4, 5, this is wrong. 1, 2, 3, 4, 5, this is wrong. And here, this is like C3H, 1, 2, 3, 4, 5, 6, 7, 8. Remember C3, CnH2n plus 2. This is an alkane. This is propane. You know, this is not C3H6. So that's why this is the right answer. On which atom is the formal charge in the hydroxide ion OH minus? Oxygen, 1, 2, 3, 4, 5, 6. Remember, it's in group 6A. Hydrogen has 1 electron. And then it has 1 electron, one negative charge, one electron. So I put it here. And then these two guys share electrons. So this would be like OH minus. Formal charge of oxygen. Remember, number of valence electrons for oxygen is 6 minus number of non-shared electrons, which are like 6, minus half of the shared electrons, which is 1, equals. I always do that. These two guys have like plus signs between them. Let me write the equation too, because I was doing that in one of my office hours too, writing the formula. I accidentally didn't write the plus sign, so you don't do the mistake that I do. So remember, oxygen is more electronegative. So if you get a positive number like myself that I was about to get, just doubt your formula. There's formal charge. Okay, you see that as we said, formal charge equals number of valence electrons in the neutral atoms, neutral atom, minus number of unshared electrons, basically the dots that we put, plus half the shared electrons. Okay, so this would be -1. And now if we do for hydrogen, am I recording? Okay. Like, am I doing all this for nothing? Number of valence electrons is 1 minus. It doesn't have any unshared. We don't have any dot around this, right? Plus half the shared electrons. Would be 0. So which atom, on which atom is the formal charge in the hydroxide ion? So it would be oxygen, right? Name the compound C10H22. So it would be decane, right? Which of the following is an alkane? CnH2n plus 2. This is not, this is not, this is not, this is right. C7H2 multiplied by 7 plus 2. Write the structure for 2-methyl butane. 4 carbons, 1, 2, 3, 4. Methyl. It would be CH3, CH2, CH3. So it would be CH3 2 times, and here we have CH, CH2, CH3, which is this one, right? Now this one, this is like, dimethyl. So it's not like 2-methyl, right? It would be 2N2 dimethyl. And this is a 1, 2, 3, 4, 5. This is a C5H12. This is like what? CnH2n plus 2. This is like pentane. And the same thing here. CH3, CH2, 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 CH3. This is also pentane. What does represent the kernel? Just AR, right? Remember, nucleus plus unshared or like field shell electrons. Which of the following structures is not correct? So here we, first of all, we have cyclopropane, yes. 1 and 1 dimethyl, this is correct. 1, 2, 3, 4, 1 and 1 dimethyl cyclobutane, this is correct. 1 and 1 diiodo cyclobutane, this is correct, but this one, 1, 2, 3, would be cyclopropane, but I said 1 and 1 3 and 3, you know, tetra, chloro, you know, we have like 1, 2, 3, 4, 5, you know, it's not tetra, chloro. And also it's not, you know, it would be 1, 2, 3. It won't be like 1 and 1, 3 and 3, you know, and then we should have another number. So this is wrong. You know, you can argue that this is for sure wrong because the other ones are correct and this is not correct. Okay, and this is like the last thing that I had here, and I just wanted to go quickly through some more materials, and this is the bonus for students who watch this by the time that I upload it and post it. And that is these questions. You know, I'm going to read it and then I hope you pay attention. Is the following statement true or false? All the bonds in alkanes are polar. And as a result, alkanes do react with molecular oxygen and the halogens. Alkanes do react with molecular oxygen and halogens. That is correct. But all the bonds are non-polar. And in general, alkanes are inert. But they do react with molecular oxygen and halogens. What is the oxidation state of oxygen in CH2? Oh, remember, usually oxidation state of oxygen is -2, and that is what I asked in this question. And oxidation of hydrogen is usually +1. And if we want to calculate oxidation state of carbon, we say 1 multiplied by carbon because we have 1 carbon +2 hydrogen because we have 2 of hydrogen +1 oxygen equals 0. The sum of oxidation states in a neutral molecule is 0. And we substitute this with +1, this one is -1, so we see +2 -2 equals 0. So carbon would be 0, right? What type of isomers cis and trans cycloalkanes are? Remember, cis and trans are the ones that we couldn't convert them to the other, and they were type of stereoisomers, and they were, okay, I'm just like, I want to go to the slide that I had. Let's go to lecture 15. No, if I go to this lecture, you see, you know, we cannot convert them, you know, by single bond rotation. So there are configurational isomers. Okay, remember? Did I delete that? Yeah, so let me go to the 14th lecture, but I explicitly have them too. Where's the slide? Sorry, I uploaded my other class. Okay. Okay, certainly didn't mean to do that, but doesn't matter because I'm not recording this one, I'm recording the Zoom. Oh. We have them here. Okay, I'm looking for 14th lecture. Hope. Okay, here. Jeez. Okay, you see like cis and trans are here, you know, and we have like, you know, we do not interconvert, you see, by single bond rotation. You know, we cannot interconvert them without breaking the carbon-carbon bond. They do not interconvert. Just like delete what I draw here. Anyway, you got the point, okay? So I asked you what type of isomers cis and trans are. Remember, you know, they are configurational. And so this can be cis trans. This can be ethane isomers. This can be like butane or like butane isobutane or like butyl. And then here we had like conformational as these examples, staggered eclipse. This is like most stable, lowest energy. Is the following statement true or false? 2 of the possible conformations of ethane are staggered and eclipsed. The high energy is the staggered. That is false, right? The low energy is staggered. Which of the following has the highest boiling point? Methane, ethane, decane, hexane. This one is the heaviest, has the most number of carbon atoms among these, so has the highest boiling point, right? Which of the following has London dispersion between their molecules? CO2, H2O, NH3, none of the above. Remember, this is non-polar, so they have like London dispersion. Okay. I'm just going to end this video so I can upload it, so hopefully you can watch it. Yeah, I guess I end the meeting and then hopefully it records.